Good day, my name is Dr. Akinsola. I'm presenting a project on development of threat hunting model using machine learning algorithms for cyber attack mitigation on Computational Science and Computational Intelligence Conference. My co-authors are Professor Olajubu E.A. and Professor Aderounmu G.A. The table of contents for this presentation is as presented: introduction, threat hunting tactics, techniques and procedures, threat hunting methods, maturity models of threat hunting metric, which is basically centered around dwell time, machine learning algorithm applications in threat hunting, the database, tools, and machine learning algorithm used in the course of this study, results and discussions, conclusion, then references. There has been a series of cyber attacks across the globe, and it has created attack scenery that is changing rapidly. Industry and organizations are increasingly being informed. But the whole idea of threat hunting is to formulate a particular model that will be able to detect unknown patterns that has hitherto constituted serious threats to the institutional infrastructures. To do this, application of machine learning is highly desirable. Machine learning is an important technique because it involves the usage of data as well as technology for data mining, and this has been applied in various domains. Therefore, this study provides solution to the problem of cyber attack and to reduce the rate by which cyber criminals gain access to organizations' data or network by developing a novel model that makes use of array of machine learning algorithms, and this will greatly prevent cyber criminals and ultimately mitigate cyber attack in the organizations. To achieve a proper threat hunting, there is a need for formulation of tactics and at the same time institute techniques and procedures that will adequately look into critical metrics that are essential in the development of the threat hunting model. There are factors that are of importance. One of such is the creation of hypotheses, and these hypotheses will help in using appropriate tools and techniques, which will enable the expansion of analysis in having incident resolving plan for threat hunting. Basically, there are 5 procedures that are of importance when it comes to the mitigation of cyber threat, especially in relation to threat hunting. The first is adequate definition of attack scenario, which is then followed by creation of hypothesis and investigation through techniques and tools. Uncover of TTP, and new patterns. Then this will inform and enrich analytics in development of trend hunting models. If there is proper definition of attack scenario, creation of hypotheses that will really be effective in the determination of how such threat hunting will be unraveled will be so easy. And this will help in making sure that adequate techniques and tools are implemented, which will help undoubtedly how to uncover threat hunting tactics, techniques, and procedures. There are indicators that are very important when it comes to threat hunting. The two basic indicators are indicator of compromise and indicator of concern. Indicator of compromise gives information on the signs of malicious activity, which is designed in a way that can help in having automated tools to look into the infrastructure for infection signs. As regards indicator of concern, data can be collected with the use of open source intelligence from available sources, and this will help in the detection of cyber attack and threat hunting. For proper development of threat hunting model, there are methods that needs to be adequately followed, and if threat hunting must be adequately institutionalized, intelligence-based hunting is the first thing that must be of concern. This is a reactive threat hunting technique with the whole focus of using inputs of intelligence like IP addresses, domain names, indication of compromise, as well as hash values. The number two methods that could be used in relation to threat hunting is hypothesis-based threat hunting. This consists of testing three hypothesis types. There are analytics-driven, intelligence-driven, and situational awareness-driven. The third important method that could be used in relation to threat hunting is investigation through indicators of attack. This is a type of threat hunting technique that is proactive, and it involves identification of advanced persistent threats as well as malware attack by leveraging on global detection playbooks. The last method that could be used is referred to as hybridized hunting. All the three methodologies, such as intelligence-based hunting, hypothesis-based threat hunting, and investigation through indicators of attack, are combined. And this allows security analysts to continue the threat hunt with the incorporation of industrial-based hunting approaches in relation to awareness of the situation with combined particular hunting demand. Maturity models of threat hunting involves 3 to 4 levels, depending on the approach that is being considered. The level 1 is referred to as initial. This relies particularly on automated alerting, and this might not really be of high level of efficiency, We then have level 1, which is the minimal level. It incorporates threat intelligence indicator searches. It has moderate and high level of routing data collections. Then the level 2, which is called procedural. This follows data analysis procedures that have been created by others. It has high or very high level of data collection routine. The level 3 is referred to as innovative. This creates new data analysis procedures, high or very high level of routing data collection is involved. We then have the level 4, which is the leading. Similar to level 3, but with one important difference in relation to automation. The maturity model of threat hunting can be used in isolation and it can be used in a combined approach. But by and large, the model must involve critical data analysis that will help in determining how data collection are of real importance on the level of maturity that will be considered. For proper measurement of the efficiency of threat hunting algorithm, there are certain metrics that can be used, but the most important one is the threat hunting metric called dwell time. This is a powerful metric that is being used in the cyber threat landscape to assess the whole process of operation of security programs, from the architecture through the operation, as well as the determination of the incident response. It is used as a transparent measure to assess how well the team or the services detects, neutralizes, and prevent threats. To do this, machine learning algorithm is of critical importance because the model building time and the model testing time plays critical role in the whole evaluation process. For proper dwell time in threat hunting, there is a need for pattern recognition, which involves the usage of artificial intelligence, and it helps not only to identify the irregularities known as threats, but threat itself will trigger threat hunting. It can also bang the door on the data that is breaking pattern. However, machine learning techniques is used for extracting threat intelligence that is of high level automatically from unlabeled sources. In the course of this research, data sets from ISOT cloud intrusion detection was used. Some machine learning algorithms such as decision tree classifier, multilayer perceptron, support vector classifier, as well as gradient boosting classifiers were used. And performance metrics such as accuracy, kappa statistics, precision recall, and F1 measures were adequately used to determine the model that are of a high level of efficiency and effectiveness in threat hunting. Tools such as packages and libraries were also used on the ISOT CID data sets, the environments such as Anaconda and the Python Jupyter notebook, and some libraries such as scikit-learn, pandas were used in the mathematical modeling and in the proper deployment of the model. The results of the performance evaluation by making use of 80-20 cross-validation ratio shows an accuracy of 99.3 with decision tree classifier, 51.20 with multi-layer perceptron, 69 with support vector classifier, and 99.25 for gradient boosting classifier. This shows clearly that decision tree classifier had better accuracy. In another vein, kappa statistics gave a value of 0.995 for decision tree classifier, and the least among the kappa statistic value is 0.355 for support vector classifier. This shows clearly that the support vector classifier is not a candidate for threat hunting model building because the value of kappa statistics tends to be 1 for a good classifier. The precision for decision tree classifier shows a value of 1.0, and that happened to be the best in relation to precision. The recall for decision tree classifier also was 1.0, followed by gradient boosting classifier 0.99, then support vector classifier 0.69, multi-layer perceptron 0.51. For the F1 score, decision tree classifier also had a value of 1.0, followed by 0.99 from gradient boosting classifier, then support vector, and lastly multi-layer perceptron. Something is of importance here. An algorithm that has got a good accuracy needs also to show good value for precision, recall, and F1 score, as well as kappa statistics. Therefore, the choice of a good algorithm in relation to threat hunting is not solely a function of the best performance in relation to accuracy, but as well as consideration to other metrics that could give hidden value that are of importance in the determination of the threat hunting. Figures 3 and 4 gives the graphical representation of the results for each metric on 80-20 cross-validation ratio. Clearly shows that decision tree classifier outperformed other algorithms. Figure 4 shows kappa statistic result with decision tree ranking pari passu with gradient boosting classifier with a little difference. Precision result shows that decision tree classifier also outperformed the remaining algorithms. For the recall results, decision tree classifier also performed outstandingly. The story is not different when it comes to the F1 score. Decision tree classifier performed, showing promising results, followed by gradient boosting, then support vector classifier, and lastly multi-layer perceptron. In conclusion, there are 5 essential factors that one needs to consider when determining the threat hunting model: the popularity, The threat hunting has become very popular due to the present dynamic environment of cybersecurity, and the attack scene is changing rapidly. Awareness. Consequently, industry and organizations are increasingly being aware of the importance of being ahead of new threats, of cyber threats. This is where threat hunting comes handy, because the whole idea of threat hunting is to have a proactive approach that detect threats that are naturally undiscovered by previous techniques and tools. Rate. It is of importance to reduce the rate of cyber attacks in the organization. Hence, supervised machine analytics is of great importance by using appropriate data sets. And in case of this study, 4 algorithms were considered on 80-20 cross validation ratio. The result. The best result from the model gave 99.3% accuracy, 0.995 kappa statistics, as well as 1.0 for precision, recall, and effort measure respectively. Therefore, the approach is that the study shows that the best machine learning algorithm for developing threat hunting model using 80-20 cross validation ratio is decision tree classifier. And the study has also revealed to us that in the formulation of threat hunting model, critical techniques, tools, and procedures must be institutionalized, which has been adequately demonstrated and applied in this study. These are the references. Thank you for listening.